Okay, guys, let me go over all the things that you need to do for this day. The first thing is the bell ringer. So for the bell ringer, you need to go to Desmos and sign up for the Desmos classroom, because I will be posting stuff there on Desmos. And what you can do, so I'll click over here and you go there and it will ask you to join, and you'll just join. And then you can go and see, oh, look, I've got all these assignments. Obviously, I've got more than just our class. But yeah, I've got all these assignments, and which ones do I need to work on? Anyway, so do that very first. And then as soon as you're done with that, then go back to the previous page, maybe. Okay, so now we'll do the group lesson, 3.1.6. Okay. All right, let's see. We probably still have this all filled in. Nope. Okay, so the first part, a figure has reflection symmetry if a reflection carries it onto itself. See an example of a quilt design that has reflection symmetry at right. Oh, that should say at left. Okay, so this quilt has reflection symmetry because you could fold it in half and they would all match up together. So yeah, or you can have a mirror right there and it would look the same. It would be, you know, it looks like there is a mirror put there and it's just a reflection of itself. Okay, so that is reflection symmetry. The next page, we're talking about what shapes have reflection symmetry. So that would be where we can fold it in half and the sides and angles will all match up perfectly. So the isosceles trapezoid and the regular pentagon. Isosceles trapezoid means that two of the sides are the same. So we've got this diagonal side and this other diagonal side that are the same. And then the regular pentagon. So a regular pentagon means that all the sides are the same length. And yes, that one we could fold in half and it would match up. Okay, reflection symmetry. Reflection symmetry is the isosceles triangle. So these two sides, the tall, long sides are the same. A rhombus, you could fold a rhombus in half and it would be the same. And same with a circle, you could fold a circle in half and it would match up as well. Okay, and this page, I accidentally duplicated the previous page. So on this page, it says, which types of triangles have reflection symmetry? So we look at all 5 of these triangles, and the ones that we could fold in half and they would match up are the isosceles right triangle, an equilateral triangle, and an isosceles triangle. The scalene triangles, scaling basically means that none of the sides are the same. So hopefully that will help you. All right, which type of quadrilaterals have reflection symmetry? Okay, so we've got all these quadrilaterals, and a quadrilateral is a shape that has 4 sides. So the kite has reflection symmetry, the rectangle, the isosceles trapezoid, and the rhombus. Okay, which shape on the previous pages have more than 3 lines of symmetry? So if we go back and we're looking at the very first page, the regular pentagon, we could fold it in half going up and down or from any of the corners. If we fold it in half from any of the corners, it would match up. Okay, let's see, the rhombus, we can fold it in half up and down or side to side. And then the circle we could fold it in half infinitely many ways and it would always match up. Okay, isosceles triangle, no, that one wouldn't work. Oh yeah, this is the same as the previous page, I forgot. Okay, the equilateral triangle, so we can fold it in half from any of its corners and it will match up. So that's 3 ways. Okay, and then a rectangle, you can fold it in half up and down or side to side. And then the rhombus, we already talked about the rhombus. Okay, oh, and this trapezoid down here, see how it says it's not isosceles? That means that the 2 diagonal sides they are not the same length. So unless it's an isosceles triangle, then it's not going to work. All right, so we've got the regular pentagon, the circle, and the equilateral triangle. And we've got a rectangle. Let me write that. Rectangle. And what else did we have? The rhombus. Oh, it said more than 3, so rectangle doesn't work. The regular pentagon, the circle, and the equilateral triangle. Okay, so I guess that's it. Okay, which shapes on the previous pages have 90-degree rotation symmetry? That is, which can be rotated about a point 90 degrees and remain unchanged. So the 2 that it will work with are the square and the circle. Okay, so yeah, reflection or rotation symmetry is where you rotate it from up and down to sideways and it will still match up. So the square will work and so will the circle. Okay. You learned that many shapes have reflection symmetry. These shapes remain unaffected when they are reflected across a line of symmetry. Similarly, some figures can also be rotated onto themselves so that they remain unchanged. Explore using this tool. So if we were to take this tool and we see this wonderful little shape and we can rotate it around, and there we go. We are at 120 degrees rotation. Now we'll rotate it a little bit more. Now we're at 240 degrees rotation. And then we rotate it some more and we're back at 360 degrees rotation. Okay. So yeah, that's a fun little tool to play with. And I just use my slidey dot to rotate it. I'm not sure if you can grab this one. Nope, you can't grab that one. Okay, so examine the shape in the toolbox link. Is it a polygon? Yes, it's a polygon. A polygon is anything that has many sides. Can this figure be rotated onto itself? Yes, it can. At 120 degrees, at 240 degrees, and also 360 degrees. All right, Jessica claims that she can rotate all polygons in such a way that they will not change. How does she do it? Well, we decided that any shape can be rotated 360 degrees and it will be the same. So if you were to take this shape, and here it is, and I were to rotate it 360 degrees, it'd be the same, right? So anytime you go 360 degrees, any kind of shape, it will be the same. All right, page 11. Since all polygons can be rotated 360 degrees without change, that is not a very special quality. However, the polygon in part A above was special because it could be rotated less than 360 degrees and still remain unchanged. A polygon with this quality is said to have rotation symmetry. Okay, so this shape right here has rotation symmetry because we can rotate it less than 360 degrees and it will rotate onto itself. Okay. All right, but what shapes have rotation symmetry? Go back to the shapes on the previous pages and identify those that have rotation symmetry. So if we go back to our shapes right here, so we see that there's a rhombus. You could rotate it 180 degrees and that would match up on itself. Let's see, what else? Oh, and the parallelogram, you can rotate it 180 degrees and it will match up on itself. The equilateral triangle will match on itself. Rhombus, we already said. Circle, of course, but it's not a polygon. The pentagon, we could do the regular pentagon. Okay, so let's go back to page, where were we at? This page, page 11. Okay, page 11. So a square and an equilateral triangle. That bell is so loud sometimes, especially when you guys aren't here. Regular pentagon and a pair of well, I know, right? Okay. All right, show me math. Okay. Is there a polygon that can be translated so that its end result is the same as the original object? If so, draw an example and explain why or why not. So if you take a shape and you move it, it's not in the same place anymore, right? So there isn't a shape that you can move and it will match up on top of its shape. Because once you move it, it's not in the same place, right? Okay. Page 13. Is there any kind of shape or figure that has translation symmetry? So a line, if I have a line, and a line, remember, goes on forever. So if I move my line back and forth, it's going to be in the same place. And also a tessellation. Remember, a tessellation is tessellation is a pattern like this, that as you move it, it'll be back on top of itself. So this is a tessellation. These are all examples of tessellations. Okay, all right. Page 14, now describe all types of symmetry for a given polygon. For example, assume you have a regular polygon with 10 sides, which is called a decagon. What reflections carry this decagon onto itself? Describe its lines of reflection. If this polygon has no line reflection symmetry, explain how you know. Okay, so with a regular decagon, that means all the sides are the same length. You can fold it in half at all of the corners, and you can fold it in half also on all of the sides. So that gives us 10 lines of symmetry. Okay. Page 15, what rotations carry this polygon onto itself? That is, describe a point of rotation and the angles for which this polygon has rotation symmetry. If this polygon has no rotation symmetry, explain how you know. Okay, so if we were to rotate it about the circle or about the center, so wherever the center is, and we were to take from, let me pick a different color, we'll go to green. If I were to take one corner and rotate it until it was on top of the next corner, then it would have rotated and it would look the same, right? So I'll just keep doing that. Take that corner, rotate it around, take the corner again and rotate it around. Okay, so if you rotate it around the center and if you rotate it 36 degrees, then it will have rotated on top of itself. And the way we figure out that it's 36 degrees, we know the whole entire shape, if we rotate it all the way around, is 360. And then we take that 360 and divide it by how many sides our shape has. So this shape has 10 sides, which means it would be 360 divided by 10, and that is 36. Okay, and the last page, what translations carry this decagon onto itself? So describe how you could move this shape and it would be on top of itself. Well, if you move it, then it's not on top of itself. So there is no translation that would make this decagon move onto itself. All right, so that is that. And then let's go back to home. And there is, oh, I forgot, it's back to pages. So we're on day 1. Okay, the learning log. Okay, so the learning log is asking you questions. Reflect on what you have learned during this lesson. Answer the questions below. When helpful, give examples. So what is symmetry? So you explain symmetry in a way that makes sense to you. You can also Google it. How can we determine whether or not a polygon has symmetry? So then we just say, oh, well, if you fold it in half, it matches up, or it is the same on both sides, however you want to explain it to yourself. And then what types of symmetry can a shape have? So there's rotation and reflection symmetry. And those are the two that we've talked about today. Okay, let me know if you have any questions, and I will be seeing you next time. Have a great day.